This is the part 2 of my 24 volt backup power station build. In this video, I'll show you the general setup of components, including a wiring diagram, how I put everything together in the toolbox, and testing at the end. Here's the list of components that went into the power station build. I explained how I selected and tested these in the part 1 video. In addition to the main components, these are the other components that were required for this power station build. Um, First one is ANL fuse, then this bus bars, main switch, battery terminal covers, power strip, battery gauge, and wiring. This is the toolbox I used for this power station. This is probably the most expensive toolboxes of this size available for purchase from different stores and brands. But for this power station, I thought this was the best choice I had, although it's relatively more expensive compared to the other choices out there in the market right now. These are the dimensions of this toolbox I selected. To set up all the components inside the toolbox, I had to build this frame. Inside the box, the frame stays like this, and the battery charger was mounted at the bottom of the frame, and the bus bars were mounted on either side of the frame. And then I cut this piece of pegboard to put it on the top of the frame to mount other components such as battery gauge, fuse, switch, and so on. I chose the pegboard because it has holes, which is good for ventilation. This is how I laid out the battery charger on the left, inverter, and the battery. The inverter was mounted on a piece of pegboard. I used the supplied hardware to mount the inverter onto the piece of pegboard like this. I applied a little bit of thread locker just to be safe, and the mounted inverter looked like this. I tried several iterations of mounting these other pieces onto the piece of pegboard on the left. This is one such example, but I did not end up using this layout. Here is the wiring diagram. The two inputs, solar panels and battery charger, in green boxes on the left, and the power output via the inverter is on the right. Some points to highlight here. I put a connector, this purple box with letter C in there. It is an Anderson connector between the battery and the bus bars, so that I can use an external battery both to charge and use with the system. One issue with this wiring is when I use that external battery, I would bypass the breaker and the fuse between the battery and the bus bars in the original system. So in terms of safety, the charge controller and the inverter both have built-in fuses, and the battery has a battery management system including low temperature cutoff protection. Additionally, there are fuses in the wires from the solar panel to charge controller, but they are not shown in this wiring diagram. For the ease of routing the wires, eventually I settled with this layout. This is the final wired setup. I had to make most of the wires I used here using appropriate lugs and ferrules and so on, but I'm not showing all those details in this video. First, I tested the charging function. As you can see, this black wire is the AC input to the battery charger. Now the gauge shows it is charging at around 19 amps. Here is the final finished product. Everything fits in this toolbox. I keep a small pouch of accessories and fuses. This is the solar connection wire. As you can see, there are two fuses which were not in the wiring diagram. This is the AC input or charging wire, and this is the power strip I used. So this power strip has both AC outputs and some USB outputs. To turn on the system, first this 60 amp fuse needs to be turned on to connect the battery to the bus bars. The gauge powers up after that, so as the charge controller, and then this main switch, once you turn it on, connects the power to the inverter. I tested the system using this 1500 watt heat gun. So I'm connecting the heat gun to the system through this kilowatt meter. First you have to turn on the inverter. Then turn on the power strip. You can see the correct voltage there, 120. No watts because the heat gun is still off. You can see when I turn on the heat gun, it would display a voltage of about 800. I cannot use the maximum or level 2 of this heat gun because then it will go 1500 watts. The inverter is rated for a maximum of 1200 watts. I have done that before in a previous video. I don't want to try that again here. I also wanted to see if I could use the system while it is charging, plugged into the wall. So I'm using this power strip connected to the wall to start charging. And the heat gun is still connected. You can see on the gauge it is charging at about 19 amps. The battery is not drained much. As you can see, it works fine while the system is charging. Here I am testing it again. So everything works perfect. Testing the system with the solar panels. This is the charging function test, but this is not a perfect day. As you can see, it is very cloudy. These solar panels are 200 watt, 40 volt rated solar panels from Amazon. These are pretty easy to unfold, but you need some effort to set the stands and get the right angle and so on. I'm just leaning part of the panel on the wall here, so this is just a test to see if the charging function works. Inside the pouch I keep the connecting wire. One end of this cable Anderson 1545 and the other end is MC4 solar connection. Regardless of very low sunlight, I decided to do the test anyway. So connect the solar panels to the system like this, and then I have to use the phone app to access the charge controller. As you can see, solar panels are operating at 12 watts. It's a very low wattage for 200 watt solar panels, about 40 volts and 0.3 amps. That's not much, but I just wanted to show that the system works as intended. As you can see, the sun is out there hiding behind the clouds somewhere. I tested to see if the system worked while charging with the solar panels and using the same heat gun at low setting here. It is going around 800 watts. So it does work. And on the gauge, you can see the positive 0.3 amps charging current going into the battery. So everything at this point works as intended. At the end of use or charging, I can unplug everything and roll up the wires like this. Keep it in the empty space on top, including this power strip, which is kind of difficult to handle because this cable of this power strip is very stiff, especially under cold weather. But I can roll it up and hide it on top of the inverter and close the box, either carry it or roll it on this dolly. I plan to install a fan connected to a thermocouple on one of these sides to prevent overheating in the future. But for now, this is the final product. Oh, I forgot to keep my pouch containing accessories and fuses inside the box. That also fits in there without any problem. This is the final completed system, which is very portable. And this is the end of this two-part series of my power station build. Thank you.